I am D. Chinnagokari. So, welcome to our chemistry channel, Chemistry Masters Academy, CM Chemistry. So, here in this video lecture, I am going to explain about chemical kinetics chapter. So, this is the lecture 2 in the chemical kinetics chapter. So, in the last video, I have explained already introduction of chemical kinetics, type of chemical reactions, and how to write the rate of reaction in the sense average rate, and also in the sense average rate and instantaneous rate. And then after I have explained to you how to write the rate of formation and rate of decomposition, and one model problem also I have explained there. In this video lecture I am going to explain you a new concept, that is how the reaction is going to takes place, or explanation for the rate of reaction. Explanation for rate of reaction. Rate of reaction. Rate of reaction. So here we can explain the rate of reaction by using two theories. Means how the reaction is going to take place, how the reactant molecule is going to be converted into product, what is happening, what are the processes happening before converting reactant into product. That is the nothing but here explanation of rate of reaction, or how the reaction is going to take place. So here we are having two theories to explain the rate of reaction. The first one is collision collision theory. Collision theory. And the second one is transition state theory. First we'll discuss about the collision theory. So how the it explains the rate of reaction. So according to this collision theory, a chemical reaction takes place due to collision of molecules, reactant molecules. For example, let us consider this is one molecule and this is another molecule. How the reaction is going to take place in between them? So when they are collide with each other. Collide means hitting to each other. So the chemical reaction, the chemical reaction, chemical reaction takes place due to collisions, due to collision of reactant molecules, reactant molecules. So here in bimolecular reactions means only two molecules are involving in the chemical reaction. Such type of reactions are called bimolecular reactions. In bimolecular reactions, in bimolecular molecular reactions, in bimolecular reactions, the rate of collision is very high. Rate of collision, rate of collision is very high. So it is 10 to the power of 25 to 10 to the power of 28 collisions per second, per second. And here each and every collision is not going to give product. Each and every collision is not going to give product, and only few collisions will give the product. So here every collision is not give product, is not give product, and only few collisions give the product. The collisions which give the product are called effective collisions. Means collisions here two types. One is the effective collision, effective collisions. Effective collision means so which gives product. The collisions which gives product, which gives product. The collisions which give product are called effective effective collisions. The collisions which give product are called effective collisions. So effective collision indicated with F. F means fraction of collisions which gives the product. And ineffective collisions. Ineffective ineffective collisions. So ineffective collisions means the collisions which are not giving the product are called ineffective collisions. So which not give product, it's not give product are called ineffective collisions. So here if a collision want to be effective, if a collision want to be effective means if a collision want to be produce a product, it should clear two barriers. One is the energy barrier and another one is the orientation barrier. So here if a collision want to be effective collision, want to be effective collision means which give product. If a collision want to be effective collision, it must clear two barriers. It must cross or clear, it must cross two barriers. Two barriers. So what are the two barriers? One is the energy barrier, energy barrier, and another one is the orientation barrier. Energy barrier and orientation barrier. Okay. So when the collision crosses these two barriers, then only it is giving to product. For example, here A and B are reacting together, A2 and B2, and they are going to give a product B. So when this reaction is gives us product means when the collision between these two molecules is effective. When this collision is effective means when it crosses these two barriers. One is the energy barrier, another one is orientation barrier. So first let us see about the energy barrier. Energy barrier. So here what is the energy barrier? So means if here a reacting molecule must possess some minimum amount of energy to give an effective collision, that minimum amount of energy is called what? Threshold energy. So here it should have some threshold. Threshold energy. So what is here threshold energy means the minimum amount of energy. The minimum amount of energy. Minimum amount of energy is required to give effective collision or to give or to result or to give effective collision, to give effective collision. So that is called what? Threshold energy. So here we will understand this what is this threshold energy by taking a graph here. So now let us see the graph here. Now let us see the graph. So we are taking the graph here. So now this is the x-axis, this is the y-axis, and this is the x-axis. On y-axis I am taking the energy, and x-axis I am taking the reaction coordinate, reaction coordinate. So here initially this is the energy of the reactant, and it is the energy of product. And if you a reactant want to convert into product, they must clear the energy barrier. So this is the energy barrier. So here this is called what? This one is called, this amount of energy is called threshold energy. Threshold energy. And here already our reactant molecule is having this much of energy. Reactant molecule is having this much of energy, and here still it is required this much of energy. Still it is required this much of energy. So this energy is called activation energy. Activation energy. This energy is called what? Activation energy. So here this black line is known as what? Threshold energy. Whatever it may be, this reactant want to convert into product, it must clear this much amount of energy. So that this much amount of energy is called threshold energy. And already here reactant molecule is having this much of energy. This is called average kinetic energy. Average kinetic energy of reactant. So already it is having this much of energy, so that still it is required this much of energy only to cross this energy barrier. So this is called what? Activation energy. So here how we are getting the activation energy? Activation energy is equal to threshold energy minus average kinetic energy. Threshold activation energy indicated with activation energy. So here activation energy is equal to, so now let us use, okay, let us use this part here, this type of part. Before that, so once again revise this collision theory. What is a collision theory? So collision theory explains the rate of reaction, means how the reaction is going to be takes place. Okay, and the chemical reaction takes place due to collision of reactant molecules. So collision means hitting together. So in bimolecular reactions, rate of collision is very high, that is 10 to the power of 28 to 10 to the power of 25 collisions per second. Every collision is not giving the product. So only effective collisions give the product, whereas ineffective collisions is not giving the product. If a collision want to be effective collision, it must cross the two barriers. One is the energy barrier, another one is the orientation barrier. So here it is the, for example, I have taken one reaction here. A2 plus B is gives rise to product. So if this reaction want to be produce this product, it should clear these two barriers. One is the energy barrier, another one is orientation barrier, energy barrier. So in energy barrier, if any reactant want to be convert product, it should cross some minimum amount of energy. That minimum amount of energy is called threshold energy. So this is the minimum amount of energy it should cross to give product in this particular reaction. In this particular reaction, a reactant is having this much of energy already, and if it clear this much of energy, it can give the product. This much of energy is called what? Activation energy. Okay, so now let us see how to find this activation energy. So here what are the some important formulas here? So first of all, threshold energy. Threshold threshold energy threshold energy is equal to threshold energy is equal to activation energy EA activation energy plus average kinetic energy of the reactant molecule. So activation energy EA is equal to threshold energy threshold energy minus average kinetic energy. So in that way we are going to find out the this activation energy. Next, so here scientist Arrhenius given one relation between the this activation energy and rate of reaction. So here from the Arrhenius relation, F is fraction of collisions is directly proportional to e to the power of minus Ea by RT. So let us consider this equation. And also according to the rate equation, rate of reaction is equal to Z into F. So where rate means rate of reaction, we already know where, and again Z is equal to number of collisions or collision frequency, and F is the fraction of collisions which give product which give product. So that is called F fraction of collision. So here rate is directly proportional to fraction of collision, and again we already know rate is equal to k into concentration to the power n. So this we will learn in the rate law or rate equation. So up to that you just assume that so rate is equal to k into concentration to the power n. K is equal to, here k is rate constant. Rate k is the rate constant. Here n is the order of reaction. What is this order of reaction? We will discuss in our next video lectures. Order of reaction. It is the order of reaction. So therefore rate is directly proportional to k, which means rate increases, k is also increases. And here from this equation 2, let us consider equation 2, and this is equation 3. So from when you observe the equation 1 and equation 2 and equation 3, we can write F is or k is directly proportional to F, and here we can write k is directly proportional to F from equation 2 and equation 3. From equation 2 and equation 3, and we can write k is directly proportional to, so F is directly proportional to, already that is e to the power of minus Ea by RT, e to the power of minus Ea by RT. So here to remove this proportionality, here we are going to keep a constant. We are going to write a constant, that is A into e to the power of minus Ea by RT. So here what are these terms here? Here we already know what is K. K is rate constant, and Ea is the activation energy. Ea is the activation energy. Then R is the ideal gas constant. Ideal gas, R is the ideal gas constant, and T is the absolute temperature, and A is called here Arrhenius constant. Arrhenius constant, or pre-exponential constant. Pre-exponential constant. Why it is called pre-exponential constant? Means it is present before the exponent. That's why it is called pre-exponential constant. Okay. So now, so this is about Arrhenius equation, which gives information about the energy barrier and energy required to activation, energy required to to give product, means to result in the effective collision. So now this Arrhenius equation we can simplify by taking the log values also. So now let us simplify this Arrhenius equation. So here, so now first, let us remove the e from the this equation. So when you want to remove the e from this equation, we can multiply with ln. Ln e is equal to 1. So that in both sides we are multiplying with the ln. So it will become ln ln k is equal to ln a. So now we can remove this e. So ea by rt, a by rt. So now let us remove this ln also. Means when you want to remove this natural log, we need to use log base 10 and multiply with the 10, 2 into 3. So if you want to write log here instead of ln, we need to multiply with the number 2.303. So here why? Because ln is equal to 2.303 log base 10. So in the place of ln, we can write 2.303 log base 10 value. So 2.303 log base 10 is equal to 2.303 log a minus ea by rt. So you send this 2.303 into the right side, to right towards right side, it will become log k is equal to 1 by 2.303 into 2.303 log a minus ea by rt. Okay, now you multiply this with 1 by 2.303, means it will become log k is equal to 2.303 log a by 2.303 minus ea by 2.303 rt. So here 2.303 2.303 will get cancelled, so that we will get log k is equal to log a minus ea by 2.303 rt. Okay. So this is the one of the important equation where we use to calculate the activation energy at a given temperature. Activation energy at a given temperature by using the log k and log a, and we can calculate any one of the variable if we are having remaining variables here. Okay. And now let us see the graph here for this Arrhenius equation. So it is called Arrhenius equation. Arrhenius equation. So here it is also called Arrhenius equation and it is also called Arrhenius equation. Now let us draw a graph for this Arrhenius equation. So now you can draw a graph. It is y-axis, and here I am taking x-axis. On y-axis I am taking log k. On x-axis I am taking 1 by t. So, and, so when you see very clearly, it will look like as the y equal to minus mx plus c graph. Y equal to minus mx plus c. So here on the y axis, what I took here log k. that is equal to minus EA by 2.303 R into 1 by T plus log A. So here 1 by T it is as the X minus A by R 2.303 it has M log A is equal to C. So here C is the intercept. Here C is the intercept, M is the slope. So here intercept on the y-axis. It is the intercept on the y-axis. So here intercept. So here we are having negative sign. That's why we are getting negative slope. Slope is decreases gradually like this. So here it is the C. What is C here? That is log A is the intercept, and here slope here we get negative slope. So that is minus M, or that is equal to slope M is equal to minus EA by 2.303 R is the slope. So this is the graphical representation of Arrhenius equation. So what is the information finally here we are getting from this equation? Means let us see. Okay. So here what is the information here we are getting? For example, let us take the temperature. First, let us write the Arrhenius equation so that you will get clarity. So here what is the Arrhenius equation? Log K is equal to log A minus EA by 2.303 RT, or ln K is equal to ln A minus EA by RT. This is the Arrhenius equation. So in this Arrhenius equation, first let us take the temperature first. So if temperature increases, what happens? Here temperature it is in the denominator term. So here minus E by RT, minus E by RT. What about minus E by RT here? Temperature is in the, first we will take the EA by RT. Okay, temperature is in the denominator term. Temperature is in denominator term means the total value decreases. EA by RT value decreases. And then what about minus EA by RT? So minus EA by RT, here EA by RT value decreases means minus EA by RT value increases. And if EA by RT increases means the total value K A by RT increases, minus A by RT increases, means this total value K react K increases. K increases means ROR is also increases. ROR means rate of reaction. We already know rate of reaction is directly proportional to K. Rate of reaction is directly proportional to K from the previous concept. Okay, which means temperature increases, rate of reaction is also increases. We can say from this equation means temperature increases, number of effective collisions increases, the more amount of product it is going to be formed. Next to activation energy. Activation energy. So here if activation energy decreases, activation energy decreases means EA by RT, EA by RT is also decreases, minus EA by RT increases, minus EA by RT increases means K value is increases, ROR is also, rate of reaction is also increases. So which means if you want to convert reactant into product, it must have low activation energy, low activation energy, or it should occur at high temperature. So this is the information here we are getting from the Arrhenius equation. So this is about Arrhenius equation and collision theory. And next let us discuss about the one more theory, that is the transition state theory, or else we will discuss that in the next video. So thank you for watching, and if you like this video, press the like button. And if you want more information, so which type of information, or is there any difficult concept to you, you can comment that is a concept, I can explain in detail. Thank you.